how are you? Last time we discussed about the chapter number 10, light, reflection and refraction. Now today we learn the same chapter in animation, like chapter number 10 same, light, reflection and refraction. So we have to start in animation. So here we observe that there is a one man. He is seated under the tree near the pond. So he observed that there is his reflection, his image. So image will be observed, the same image of this man will be observed due to the reflection of the light. So here there are another example. There is a one man stand opposite the plane mirror. So observe that image will be observed. So this image will be observed the light reflection. Without light we cannot be observed the image. Similarly, the one boy observe the same, that is observe the image in a water. So due to all these are reflection of the light. So this is polished surface, okay, water medium, glass medium, these are all polished surface. So here in this exam, that is at the end of this lesson, that is here reflection, terms of related to reflection, incident ray, reflected ray and normal. Another one, laws of reflection, images, identify the characteristics of image formed by the plane mirror, convex mirror and concave mirror. Apply the mirror formula and sign convention to find out the relationship between the distance of object and image from the mirror. So all these points we have to discuss in this chapter. So here reflection of the light, it is the bouncing back to the incident is termed as the reflection of the light. So here this is the incident ray, this is the reflected ray and this is the normal at the point, that is the plane surface. So here next that is the type of the reflection. So there are two types of the reflection, regular reflection and irregular reflection. In a regular reflection we observe that is a plane mirror. So all the rays are incidents on the plane mirror and reflect back parallel in our eyes, and such type of reflection is known as the regular reflection. As an example, that is a plane disc, glass disc, these are regular reflection. Now in irregular reflection, that is incidence ray will be reflected and goes, that is a parallel in any direction. Such type of the reflection, it is known as the irregular reflection. So these are all the examples related to the irregular reflection. Here the general terms related with reflection, that is a plane mirror. As we know that these are the incident ray, okay. So incident ray will be at the point O. So obviously it will be reflected back in the opposite direction. Here O is the point of incidence. Let us consider. So for that here from the point O drew the normal, okay. So here normal ray and the plane surface, this is 90 degree. Incident ray and normal, this angle is known as the incident angle. Similarly the normal and the reflected, this angle it is known as the reflected angle. So here let us consider that is a verifying laws of reflection by the one experiment here. So for that here we consider that is a one paper, that will be cardboard paper. We should be draw the line with the help of the scale. Let us, its name is mm dash. At midpoint is origin O. Draw the normal, that is from point O. These are the incident ray. Draw with the help of the scale and pencil. These are known as the incident ray, and this angle is the 90 degree. Okay. And now fix the plane mirror on mm dash line. So we observe that in a plane mirror, that it will be reflected, that is P dash Q dash, this in this opposite direction. And from this opposite direction, with the help of the scale, we draw the another line will be expanded, okay, in the same plane. Okay, let us will be Q1, P1 point and draw the line with the help of the scale. So here, so it obeys the laws of the reflection. Here, the angle of incidence is equal to the angle of reflection. That is this angle, that is incident angle, and these are the reflection angle. So here incident angle equal to the reflected angle. So here the point P and Q, all these are in the same plane. So where verify the angle of incident, that is angle of incidence equal to angle of reflection, laws of reflection first. Second, incident angle, reflected ray and normal, all are lie in the same plane. So these are the laws of reflection. Now we discuss about the mirror. There is a plane mirror. The one boy comes towards the mirror and observe the mirror of his own image with the reflection of the light. The surface capable of reflecting sufficient undergoes light to form an image of an object placed in form of it is known. These are the image. Okay, these are the characteristics of the mirror. So there are two types of image: real image and virtual image. Real image we can be observed on the screen. We can be take this image in a, that is on the board, that is real image. While virtual image we cannot be obtained on the screen. Okay, these are the difference between the image and virtual image. There are two types of the mirror, that is spherical mirror, plane mirror and spherical mirror. Plane mirror which have the flat surfaces, while in spherical mirror which have curved surfaces. So these are the difference between the spherical mirror and plane mirror. So here we discuss about the plane mirror. As we know that in the morning we should comb our hair. Okay, we observe our image in the plane mirror. This plane mirror will be observed, that is a silver coating. These are the silver coating in a plane mirror. So incident ray and reflected rays, okay, both are in a, that is point O, that reflected back. So consider the image formed in a plane mirror. We should take the one plane mirror, and let us consider the object P should be right here. So from the point P at the end, rays will be reflected, that is incident ray, and reflected ray comes back to our eyes. So that is angle of incidence equal to angle of reflection, obeys the laws of the reflection. Another ray should be take here, another incident ray, that is from the point X, okay, and reflected back in our scene. So these are the incident angle and reflected angles, both are the same and obeys the laws of the reflection. Here we will extend this in our eye here. So we obtain the image of this same object. Okay, that is literally inverted. We should be obtained that XS is the image of this object. Consider from the Y point, it will be incident ray and reflected back in our eyes. Okay. Similarly, from the point Y, another incident ray and reflected back in our eyes, it will be extended. Okay. Extended at the lower point, and we obtain the complete image in mirror. Okay, so these rays will be extended. So height will be same. Height of the object will be same, will be obtained. So here these are the characteristics of the plane mirror. The height, it should be same. The distance, object distance is equal to the image distance, it will be same. Okay, so here these are the object P. The image will be literally inverted. We should be opposite direction to that is erect. It also erect. A literally inverted image will be obtained. So here the distance of object is equal to the distance of image. We both are the same. So here the relation between the object distance and the image distance we should be obtained. These are the object. Obviously in a mirror we should be obtain the image. Okay. So let us consider the O is the object. These are the incident ray on the top of the mirror, that is at the point it will be incident ray, and afterwards from the point O, let B is the incident ray, it will be reflected back towards the C direction, that is in BC direction. So here these are the incident ray, reflected ray, these are the reflected ray and normal too, and obeys the laws of the reflection here. So this will be extended Okay, both. So image will be obtained inside the mirror, like O dash is the image. So here triangle OAB is equal to triangle O dash AB. Both are the 90-degree angle. So angle of incidence is equal to the angle of reflection, and O is the loss of the reflection here. Incident angle equal to the reflected angles. O is the loss of the reflection. So both the angles are the same here. So here angle I, these are the incident angle, is equal to angle BOA. These are the alternate angles. Similarly here angle R, that is angle R, okay, that is NPC. These are the reflected angle, that is alternate angle BOA. So NPC, that is angle R, equal to BO dash A, this correspondence angle. So angle BOA is equal to the angle BO dash A. Both are the equal. Thus in triangle OAB and triangle BO dash A, okay, both angles are the same, triangle will be same. So AB is the common side. Here AB is the common side. Now using the angle and angle of side property, equal triangles. So triangle OAB is equal to triangle BO dash A. Both are the same, equivalent. Both are the equivalent triangles. So we can observe that here both are the images, that is half image, that is the full images we can be observed. These are the characteristics of the mirror. That is, the mirror will be short. So obviously our image will be half, we should be observed in the image. Here mirror is the large images, because due to the large plane mirror, obviously our image will be in full length. So here we are, how tall a mirror do you require? So in this experiment here, let us consider there is a one boy, let his height from head to foot, that is HF. H means head and F means foot. Let us consider it will be HF is the height. Let MN dash is the length of the mirror. Its height is A and B, stick in the wall mirror. So from the point A, so here HF is equal to AB. So obviously from the point A is incident light, and F is the incident ray. Obviously it will be reflected back in our eyes, and image will be obtained in a plane mirror in the same height. So here height will be same. So obviously I previously discussed about the triangle, that is both triangle HE dash. So here AM parallel HE, and A is midpoint of HS. So M is the midpoint of H dash E. Similarly another triangle FEE dash. So here NB parallel EF, and B is the midpoint of FF dash. So here N is the midpoint of F dash A, and another consider, that is triangle here H dash F dash E. So N is the midpoint of H dash E. So M is the midpoint of F dash E, and N is the midpoint of F dash E. So from this relation we can be obtained, that is MN parallel H dash F dash, and MN equal to H dash F dash divided by 2. So it will be obtained, that is H dash twice HF, that is here HF divided by 2. MN is equal to HF divided by 2. So height, that is image height, will be decreased half of its length. In order to see this full length image, a person require plane mirror, that is half his own height, and we have to be proved mathematically. Here the length of the mirror required to view the complete images in this mirror. Another example we should require, that is here the effect of the rotation of the mirror. The mirror will be rotation of the reflected rays. So these are the reflected ray, incident ray from the sun, and the rays will be reflected towards the one girl. When the rotation of the mirror, the angle of incident and angle of reflected, both are the changes here continuously. So these are the incident angle, these are the incident ray from the sun, and at the 120 degree it will be reflected back towards the girl here. Now this reflected ray, the incident angle will be changed whenever rotating the mirror. The reflected angle is also changed. So let us consider this is the plane mirror, M1, M2 surface of the plane mirror. R is the incident ray, sun rays, and reflected rays. According to the laws of the reflection, drew the normal incident angle and reflected angles both are the equal. So here let us consider ION is the incident angle and another that is the ION. There is the laws of the reflection and incident angles and reflected angles both are equal. Now we have to change the route, that is direction will be changed. So IOR equal to twice incident angle. So here, so normal n dash, n2 n dash it will be changed. So as the direction will be changed, m1 dash, m2 dash it will be changed. The reflected angle is also changed. It means comes in theta will be changes. Some minor will be changed. So incident angle I plus theta. Incident angle plus theta will be variation. Because we have to be slight, that is inclined. The plane will be rotated. So here m1 dash and m2 dash, the change will be obtained theta, that is IOR dash equal to angle ION dash plus here angle n dash OR dash. So here this angle equal to both, that is angle IOR dash equal to angle ION dash plus angle n dash OR dash. But here that is angle ION, that is angle I plus theta, incident angle plus theta, minor changes. Similarly here plus incident angle plus theta. So it is twice I plus I, twice I plus 2 theta. So subtracting 1 from 2 we have obtained twice I plus twice theta minus twice angle I. So both it will be cancelled and we obtain twice theta, angle twice theta. So for a given incident ray, if a plane mirror is rotated through a certain angle, then the reflected angle rotates to twice that angle. So it means that is twice theta will be here. Incident angle will be changed by rotating the plane mirror. The reflected angle will be twice and will be changed, and which is true in your eyes. So here, so these are the example related to the effect of rotation of the mirror by the reflected rays. So here we take another example, that is a mirror placed at an angle, different angle, that is here 3 mirrors will be arranged here, plane mirror. So that is mirror 1, mirror 2 and mirror 3. So these are the that is objecto. So these are the incident ray. Okay, it will be reflected, multiple reflection. In a general we can be observed in a periscope, multiple reflection by the arranging of the 3 plane mirrors. So we should be obtained, that is number of images we can be count, that is n equal to 360 upon theta minus 1, where n is the number of images. Here that is 2 plane mirror and should be kept at a certain angle. So image should be obtained, that is 1 here. That is theta is 0 degree here, that is plane mirror. So n equal to infinite number of images should be obtained in a plane mirror. Both are parallel to each other. Okay. So number of images are so many, infinite number of images should be obtained. So let us consider that is a incident angle, that is a object. It should be both are the image should be obtained in inside the mirror. Now generally we should be observe the periscope. In a periscope, that is we should be obtained there, that is to see the submarines in our ocean or the sea. We observe use the periscope. For the far distance, we can observe the submarines or the ship comes towards the edge. So here in a periscope, there is a one hollow tube and one plane mirror should be kept at a certain degree angle, and another mirror should be kept at a certain degree angle. So incident objects, it will be incident ray, that is reflected ray, and towards our eyes. So here in a periscope also there is another this type of plane mirror should be observed in a using hall you can be observed, and sometimes we should be observe our image in a different manner, like that is a fat thing, that is our funny face should be observed in sometimes due to the changing the angle of reflection, okay, of the plane mirror. Here that is the object and these are the image. Image will be different due to the changes of the angle of reflection and the plane spherical mirror. Now this type of spherical mirror we can be observed generally when we use. So in our vehicle, okay, spherical mirror should be obtained. Generally, these are the mirror we should be observed in a vehicle to observe the right side of the object. So at the end of this lesson, we will be able to describe the spherical mirror, identify the characteristics of image formed by the convex mirror and concave mirror, apply the mirror formula and sign convention to find out the relation between the distance of the object and image from the plane mirror. So here, spherical mirror, that is considered as a sphere. Now, you should be got the one mirror that is in curved mirror, okay, and this curved mirror, these are the spherical mirror from the spherical shape. So there are two types of the mirror, convex mirror and concave mirror. The spherical shell should be cut, that is our one. Mirror should be obtained from the spherical shell. Convex mirror, and this convex mirror generally used in a vehicle. While concave mirror, it should be observed, that is, it should be obtained. That is, inside the curve, it will be reflected, and outside curve is the colored portion. And this concave mirror, generally, is the dentist, doctor, you should be use concave mirror. Now, some terms are related to the spherical mirror, that is the spherical shell. Okay, the center portion of the shell, it is known as the center of curvature of the given mirror. Now, the distance between the center of curvature and at the end of this part, that is radius of curvature, it is known as the radius of curvature, that is capital R. The center portion of the mirror, center part, is known as the pole, and the diameter of this mirror, it is known as the aperture. Now the principal axis and imaginary line passing through the center of curvature and the pole, and this line, it is known as the principal axis. So here, all these are the definitions related to the spherical mirror. Now the focal length, the distance between the focal length, the focal point and the pole, the distance, it is known as the focal length. Sometimes we observe in a mirror, this written, objects seen in the mirror are closer than they appear. Always this type of statement we can be observed in the plane mirror, spherical mirror. Okay, it means that that is very closer. Objects seen in the mirror are closer than they appear. Okay, it's very closer perpendicular to outside that medium you should observe. So here we should be considered as a reflection of convex mirror. That is the convex mirror. All these are the incident ray, okay, and reflected back. So these are the reflection of convex mirror. That is center of curvature, principal focus, pole. These are the principal axis, okay. So first we take the incident ray parallel to the principal axis. Now this incident ray parallel to the principal axis, obviously it will be reflected back. It will be extended. It passes through the principal focus, that is F. So here incident angle and reflected angles both are laws and always the laws of the reflection. Similarly, another take example, that is here incident ray. Okay, it passes through the center of curvature, and after the reflection, angle of incidence is the 0. After the reflection, it goes back parallel to the principal axis. So related towards the C, incident angle. So the same process that will be, appears to pass through the center of curvature. Incident ray and reflected, the path will be same. It reflected back. Here, another this third point, it passes through the principal, incident ray passes through the principal focus. So it will be reflected back parallel to the principal axis, and obeys the angle of incident and angle of reflected, both are the same here. So I have to pass parallel to the principal axis. Now it passes at the pole P and obeys the laws of the reflection. Okay, incident angle and reflected angles both are the same. So make the same angle with the principal axis. Now dentist reflected, that is concave. Most of the dentists or the doctor use the concave mirror. Okay, so here reflection of the mirror, that is, image should be obtained, that is enlarged, it should be obtained. So here, that is for the concave mirror, all the rays are incidents, okay, in a concave mirror and reflected back at the one point at the principal focus. So these are the incident ray. In a principal focus, it passes to the principal focus. Incident angle, that is incident ray from the center of curvature, and the same path it move back in the center of curvature, okay, the same path. Similarly, the incident angle passes through the principal focus, it goes back parallel to the principal axis. So here, now at the end, that is at the principal focus P, it moves towards, okay, come back towards the opposite direction, obeys the incident loss, that is reflected rho. Now, relation between the focal length and radius of curvature of a spherical mirror. So,